Okay, I get to stand up, I didn't realize. But
I already said
Stefan
that.
had to see me get sit down. I just have a quick, so I'm not gonna also, it's how I became a mathematician. It happened. We all have stories.
Sorry, no worries.
That's right. But a quick comment on kind of the gathering. I think this is a great idea that you all get to ask why you have to take the courses you have to take. Because it makes sure we thought about them, and we did. In your case, it wasn't a lot of thought because somebody else told us to teach these to you, right? So the state tells us the courses and the content you need, and we kind of hope somebody's asking them. But for any of our students, if we're making you do something, I think it's a legitimate question, why are you making us do this? Okay. So I'm going to start with just a quick answer to the question, why should people who are going to teach high school, grammar school math take high math? And it's not going to be as mathematically insightful as this. It's just a quick question. Here's the question. You have the earth, and you have a yellow string. You take the yellow string and wrap it all the way around the earth tightly. Okay, yellow string. Now you have a red string. And you wrap it all the way around the earth, but not tightly, 1 inch out, the whole way around. Which is bigger? No, that's too easy. Right, the red one's bigger than the yellow one. How much bigger? Is it 7 million miles, 7,000 miles, 700 miles, or 7 inches?
Biology for calci, is that cheating?
I do this all the time.
So it's 2 pi bigger.
It's 2 pi inches bigger. So it's about 7 inches bigger, about this much bigger. Okay. Why is it important that, so by the way, that fact, just to go to properties, that's not, right? If R is the radius of the earth, the what was the first color, yellow?
Yellow.
Right. The yellow is 2 pi r big, and the white, red.
It was red.
I guess that's not the important one. Was 2 pi r plus 1 inches bigger. And the distributive rule says that this one is just 2 pi inches bigger. 2 pi is 6.28 something something, so about 7 inches. Another fascinating fact about this is, you see how big R is? That's because it was the Earth. It's also true if it was a dime. You took a yellow string, wrapped it around a dime, and a red string and wrapped around a dime 1 inch out, the red string would be 7 inches bigger. When did I figured that out by myself. Not the distributive rule. Somebody taught me the distributive rule. And like was said, they said, here's the distributive rule. Remember, it'll be on a test, and we never used it. Here's a great use of that. When did I figure this out? Turns out, in grad school, I was dating a crazy person. 2 reasons she was crazy. One is the obvious. You know what I mean? The other one was she was math grad school. So, both of those things. Anyway, she decided we needed a fire pit in our backyard. So I had to shovel out a big circle and line it with fire bricks, and then she wanted, well, that's not good enough, it has to be 2 tiers.
Sounds like my mom.
Your mom's name? No. So I needed a second, and I was surprised, and I figured out, I wonder how many bricks I'll need for the second thing, so I was just comparing, and I was surprised that fact. As you have, those of you who know me know, I'm not an idiot. Took me to graduate school to understand this surprising fact. Maybe you weren't surprised by it, but this is a fact that everybody in high school could know, should understand at least, right? But I didn't know it until I had all the math you're taking, and then the really hard stuff. By the way, none of which was interesting applications of the distributive rule to strings on the earth. Right? I didn't take a course in that at all. It's just being surrounded by numbers and mathy stuff when I had to do this horrible task of, there were dead raccoons back there, digging them up. Anyway, I had to do this horrible task. That's when that made sense to me. So I think that's kind of the general answer to why should those people who are going to be teaching math as a living to people who going to learn math, why should they know a lot more math than they're ever going to teach? And the answer is, the more math you know, the better you understand what you already knew. Right, I knew this. By the way, when I first got here, I was teaching geometry class. One of my students was a returning student. He was older than me at the time. Not older than me now, but older than me at the time. And his wife was a math high school teacher. And he was stunned by this fact. Took it home to his wife and said, "You'll never guess what I learned today in school. Yellow string, red string, only 7 inches." And his wife, of course, I don't believe that, because it turns out that's what wives do when husbands tell them things. And then what husbands do, bad idea by the way, is proved it. Wives don't go for that at all. But anyway, so he proved it, and then she said, high school math teacher, "Oh, maybe that formula doesn't work on big circles." Okay. You don't want to be that high school teacher, right? You want to be the high school student. "Oh yeah, I didn't think of that way. But now I am thinking about it that way. I see it, and it's great. And you can bring this thing." I never got the chance. I wanted to give my daughter to have a science fair. And I was going to give her 4 feet of rope and prove that she can enclose any area in 4 feet of rope.
They're gonna give her the 2 strings.
Well, I was just going to give her, well, the idea, right. So, of course, do you want to include any area? Here. Start out with this much, add 4 feet of rope. You can go a foot further in each direction, and this distance here, the new distance I'm enclosing, gets arbitrarily large. So you can, with just 4 more feet of rope, you can enclose as much area as you feel like. Never got the chance to send her to school with that. Rats. She had to do something. My wife's a scientist. So that's more than time I wanted to spend on that. A quick now I'd like to just narrow down to why geometry. Let's start with, I know some of you are in my geometry class, and some of you have already enjoyed my geometry class to a certain amount. It is not, right, City, a methods course. You do not learn anything that will help you teach geometry. Hopefully, there's good people teaching you how to do that. Hopefully, the Dr. Liebars and the people in the ed school are doing the how to teach stuff. Instead, I'm teaching geometry. There are benefits to it that I think the key thing, and I think it's one of the things that people noticed in my course, especially those who are taking it now as it got worse, I'm putting a lot of emphasis on how well students are communicating mathematics. So every week, students have to type math with their fingers, on a keyboard, and then submit it, which nobody, right? We all type math all the time. My daughter's high school math teacher types math all the time. But you all are out on that practice. So we're doing that, how to type math and how to communicate math. That's what you'll be doing for a living, communicating math. And the first rule you'll have to realize is when you communicate math, you cannot use pronouns. You cannot say, "Oh, you take it and move it to the other side." You have to say, "We take the 9 and subtract the 9 from both sides." Right? No its. Right? So that's the first thing. That's why we have variables, to get away from pronouns. First goal of the course should be the goal of all your upper level courses, how to communicate mathematics effectively. Right? In geometry, the other courses, there's kind of 3 things we're doing. What is an axiomatic system? Rigid motions of the Euclidean plane, and hyperbolic geometry. How much hyperbolic geometry did you get to teach in high school?
0.
No, rats. Doesn't that stink? Right.
Yeah,
So
I was really
you were disappointed.
disappointed about it.
Right, so, right, none of that, well, you do axiomatics, right? That's where you begin two-column proofs, axiomatics. But I think we, as teachers, need more of a, here are the 6 axioms we're going to use. Right, we need to know why they were chosen. Did it have to be those 6? Could it have been other 6? What would happen if I changed one and negated it? Would that have been a problem? And the point of our class, geometry, is it's not a problem. You just get something different. Whatever. That's hyperbolic geometry. So that's the axiomatics. Rigid motions. Oh, I love rigid motions. Here's a great question. So, and I think it's true. In my class, there is a lot of figuring stuff out, which doesn't happen in high school geometry classes. Here's 3 points. So there's an easy thing, and I don't do that. You know that stuff with the, and the you know what that mean? That meant? I was driving buses. I was, the compass. You know those rule on compass constructions? And my high school geometry teacher was awesome. He could do it with one hand. You know, didn't have to just did the whole thing. I don't do that. I do everything by hand. But here's a easy construction you do in high school geometry. Given 3 points, A, B, and C is on some line L. Find a point D, this distance away from C on L. So it's an easy high school construction. You take your compass, stick it there, put one end here, swipe, and that's the point D. In fact, if you swipe more, you get a second point. For those of you who are sick of listening, should be easy enough. There's 2 points, A and B. C is on this line because 9 plus 2 is 11. Just find a point on this line that's this far away from C. How hard could that be? It's easy geometrically. It's hard figuring it out. I'll leave it to you. So that's the other point of this course I teach, is how to take the geometry we know and apply it to things which we should be able to calculate. And the last thing, if I have time, is then we go into hyperbolic geometry. What is the benefit to you all of learning hyperbolic geometry? I think it's learning a geometry you don't know. Because what are you going to be doing in a couple of years? Teaching a geometry to people who don't know it. So the most recent experience you had of trying to figure that out and conquer what geometry is, and the best way to do it is, here's a different one. Here's hyperbolic geometry. It's different than the one you're used to. I think, at least if nothing else, you'll know how your students are suffering. Okay, thank you.